So today we start our new unit by looking at calculating distance on a coordinate plane. So given some coordinate points, XY points, how can we find the distance between these two? So before we launch into the formula that you're going to need to learn to do this, let's actually go back to something that you've seen before. So you've already worked with the Pythagorean theorem. So don't forget, looking at that idea, Pythagorean theorem is our a squared plus b squared equals c squared. And your c squared is always coming from your c value or your hypotenuse, aka your longest side on your right triangle. So we can actually use this to find distances on the coordinate plane by drawing in the right triangle that we would actually be making with the hypotenuse ending in our two endpoints. So let's draw this out on the graph. So our first point is going to be 4, 5. So again, count over 4 to the right, up 5 units. So there's our first point, and our second point is at -3, -4. So -3, again, from the origin, left 3, down 4. We're looking for the distance between these 2 points. And so one of the ways we could do this, and again, let me change my color. So let's change over to purple for this one. If I actually sketch in the right triangle that this red line is the hypotenuse, or the red segment is the hypotenuse for, I go straight down from my top point and straight across from my bottom point. I make a right triangle with a right angle in that bottom right corner. And I could have, if I wanted to, actually drawn that up to the left instead. However, I now have some nice straight lines. Now, our kicker with finding distance on the plane is we can't necessarily count out our spaces if we're going diagonal, but we can count them out if we're going either straight horizontal or straight vertical. So on our vertical, again, I'm counting kind of the boxes that they go through. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 units on our vertical side, and on our horizontal side, 1, 2, 3, 4, 5, 6, 7. We have 7 on our horizontal side. So if we want to find the distance between my 2 points, going back to red, and let's see that. So going between our points 4, 5 and -3, -4, to find that distance, we can really just solve for c using Pythagorean theorem. So if we go a squared plus b squared equals c squared, we know our a and our b, those are our straight sides. And again, it doesn't matter which order we use them in. So I'm going to do 7 squared plus 9 squared equals c squared. And then I need to simplify. So 7 squared is really 49. 9 squared is 81. So that's our c squared. If we add these together using my handy dandy calculator, 49 plus 81 is going to give us 130 is our c squared. And then, well, wait a second, we're trying to solve for c. How can we get rid of the squared? What's an opposite operation from squaring something? So we can actually take the square root. And I'm also going to kind of flip this around a little bit. So c squared equals 130, aka c equals the square root of 130. Now, 130 is not a perfect square. I don't know any numbers that I can multiply by themselves to make up to 130. So as we're working on these problems, there's 2 ways you can leave your answers. My suggestion would actually be leave this as a square root. If I simplify this out, and again, plugging in my calculator, I can plug in square root of 130, and that gives me approximately 11.4018. But that's rounded off at 4 decimal places, or my 10,000ths, or excuse me, my thousandths position. And no, that is my 10,000ths position. And unfortunately, that's just not an exact answer. The square root of 130 is a lot more accurate because I don't have to round off, I don't have to truncate, it's just square root of 130. So in these problems that we're looking at today, it's actually a lot better, unless the directions say leave your answer to the nearest 10th or to the nearest 100th, then it's actually more accurate to just leave it as a square root if you can't simplify that to a straight, whole number. So I would say my distance, or my answer for c squared, is actually square root 130. So where this formula is actually going to come from that we're using, it's actually a variation of our Pythagorean theorem that we just did. So let's think about this. we did 2 points. So we had the point 4, 5, and we had the point -3, -4. So if I label those as x1, y1 and x2, y2, and again, those are subscripts that you see. So the x1, y1, x2, y2, those are called subscripts because they're written a little bit sub or below the regular line of text. And we can use that just to identify the 2 points that we looked at. So let's call our first one, again, let me change colors. So if I call my point 4, 5, let's call that x1, y1. And I call my second point -3, -4, let's call -3, x2, and -4, y2. Well, let's think about how we could have actually arrived at those values for the 7 and the 9. So if I look at 4 and -3, what would happen if I did 4 minus a -3? Well, minus negative really actually flips over to plus a positive. And wait a second, 4 plus 3 is 7, and that's exactly the length that we found in that horizontal distance on our graph. Let's see, will it work for the y's? So let's see here. Let me try that with the y's. Okay, so my y values were 5 and -4. So if I do 5 minus a -4, wait a second, that's 5 plus +4, which is 9, and that's exactly the same distance we found on that vertical side. So if we kind of put these together, if we subtract our x coordinates and we subtract our y coordinates, and then we put them together like we did with Pythagorean theorem, and then think about our last step when we solved for Pythagorean theorem, we actually took our square root. All of those are kind of mashed together in the distance formula that you see down below. So we can actually combine this. So if we're given any 2 points, and again, in general, we're going to call those points, just for posterity, x1, y1, and x2, y2. We can find the distance between those points with the formula x2 minus x1, and we square it just like we did in Pythagorean theorem, and then y2 minus y1, and again squared just like we did in Pythagorean theorem, and we have the big square root over all of that, and that's the same thing as taking the square root at the last step of our Pythagorean theorem. Now, 2 things that you might notice. So you notice I wrote down x2 minus x1. Well, it really doesn't matter which order you use as long as you use a consistent order. So if you write down x1 minus x2, then you have to write down y1 minus y2. Always subtract in the same order that you were given those points in. All right, so let's try a few problems, okay? So you might be asking me, well, why don't I just use Pythagorean theorem the whole time? Well, look at problem number 1. So problem number 1 has 2 points, one at A, 0, 0, and one at B, coordinate 6, 8. So think about that for a second. The graph I provided you only counts up to 5. So how would I actually graph out that 0.68? You'd say, well, okay, just go get a bigger graph. Well, what if those numbers were a lot larger? So if I had numbers like 25 or 102 or, outstandingly big numbers, I'm not going to want to graph those out just to be able to find the distance. And that's where this formula comes in handy. So let's attack these with distance formula and just see how it goes. So first problem. Again, I find that it's a lot easier when I do these to actually label my points with an x1, y1, and x2, y2. And again, it doesn't matter which one you choose as x1, y1 versus x2, y2, as long as you are keeping those values on the same spot, and it's just going to help us keep everything in order. So our distance is going to be, and if I do x2 minus x1, and actually, never a bad idea. Let's actually do this first problem. Let's write out the full formula all together. So y2 minus y1 squared. So then let's just fill in what we labeled. So our x2 we labeled as 6, x1 we labeled as 0. y2 we labeled as 8, y1 we labeled, that was 0, always taking the square root. So if we simplify that, wait a second, anything minus 0 is just itself. So this is just really 6 squared plus 8 squared. And you'll notice I'm taking the time every step to write down that square root symbol. A lot of times, and I have seen this happen even with advanced students, when they forget to write the square root, they forget to take the square root at the end of the problem. So always write everything down in all of your steps. It's always a good rule of thumb in algebra. So again, let's simplify. So 6 squared is going to give us 64. Excuse me, my brain's jumping ahead, isn't it? 6 squared is 36. 8 squared is 64. And when I add those together, I get the square root of 100. But wait a second, 100 is a perfect square. And even if you check that on the calculator, you get out perfect square root of 100 is 10. Now, this is one of the things that you might want to go back and review. It's always a good idea. If you remember all of your square root values, then it makes it a lot easier for simplifying these kinds of problems. Okay, let's try another one. So what's the distance between R and S? Again, just to change it up, I'm going to change over to blue ink. So I'm going to label x1, y1, x2, y2. And same thing, I'm going to plug them straight in. So again, good idea to write the formula out the first few times that you're doing this. So x2 minus x1 all squared plus y2 minus y1 all squared, all under the square root. Start filling your values in. So our x2 I labeled as 0, x1 was a -2, and I do actually like to write out minus a negative until I'm at my simplifying step, because I don't want to forget that that's in there. y2 was 9, minus y1 was 5, all under square root. So then we simplify 0 minus -2, well, that's the same thing as plus a positive. So we're looking at 2 squared. And 9 minus 5 is 4 squared. Simplify that out, we're looking at 2 squared is 4, and 4 squared is 16. So we're looking at the square root of 20. And so this is where we might need to do some simplifying. So I'm going to post an extra help video on this, so please do watch this if you don't remember this from Algebra 1. But it's always a good idea to actually simplify out our radical. So I know that the square root of 20 is really 4 times 5, but I know the square root of 4 is really 2. So I could write this as 2 root 5 as my solution. And again, this is a lot more accurate than doing your decimal version. But again, pay attention to your directions. Sometimes the directions of the problem will say round your answer to the nearest hundredth. And so that's when you would want to plug that into your calculator and give a numerical value. And in fact, I'm going to do that on the next problem just to show you, the difference between them. Alrighty, so number 3. And again, feel free to pause if you need to. Okay, distance between M and N. So at this point, and I've practiced writing out my formula, so I'm just going to go ahead and label and plug them in. So x1, y1, x2, y2. So my distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And we take the square root. So we go through and simplify. 9 minus 1 gives me an 8. 13 minus 4 is, or minus -4 is really 13 plus a positive 4, so that's 17 squared. Again, 8 squared is 64. 17, that's not one of those common ones that you might not necessarily remember. That is 289. And so 64 plus 289 gives me 353 square root. Wait a second, 353, I don't think that's a perfect square. So let's see, square root of 353, that gives me like 18. So just to check, I'm going to do 17 squared, which comes out to 289, way too small. And I'm going to check 18 squared, again, still a little small, 324. So let's try 19 squared, and I'm getting 361. I'm already way too high. So this is one that I definitely wouldn't be able to simplify it. But if the problem said, hey, leave your answer to the nearest hundredth or nearest, however many decimals, then we could plug into our calculator square root 353. And that comes out to 18.7883. Oops, no square root needed on that. So let me undo that. So 18.7883. Again, I've got my approximately equal sign on there because it definitely is not equal to that number. It's only roughly or approximately that value. All right, and you'll notice I'm leaving my answers to 4 decimal places just because I want to be super accurate on them. Okay, go ahead and pause the video real quick, and I want you to try out problem number 4 and see what happens, especially with your negative numbers. Okay, so now that you've tried that, let's check our work. Okay, so x1, y1, x2, y2. So our distance equals -9 minus -12 plus 6 minus 2. Alrighty, so -9 plus 12 is going to give me a +3. And 6 minus 2 is going to give me a 4. Otherwise known as 9 plus 16, or square root of 25. Hey, wait a second, square root of 25 comes out beautifully. So my full answer at the end is a 5, nice integer number. Now, don't forget too, occasionally you're going to come across something, and if you choose a different order when you're trying out the problems, you might have a negative number. So just to show you what I'm talking about and to see the other way that you might arrange this, if we had chosen to do the other order, so maybe switching them up, so -12 minus -9, plus 2 minus 6, check out what happens. So -12 minus a -9, aka -12 plus 9, is actually going to give me a -3. 2 minus 6 gives me a -4. And so don't forget, when you're looking at squaring negative numbers, what happens? So -3 times -3 should give you a +9. Now, if your calculator is not giving that out, keep in mind, notice how I'm writing my answer or my work. I'm keeping my numbers in parentheses. So if you're typing this into a graphing calculator like one of these guys, you have to be careful that you type parentheses around your negative number, then square your value. So be very careful with that. I will be turning on the scientific calculator that you can use on your assignments. So please don't worry if you don't have a physical calculator, you will absolutely have one available for your online practice and any assessments. So just to finish this up, to make sure that it comes out to the same answer, -3 squared gives us 9, -4 squared gives us 16, and we're right back where we were at that previous step. So that still comes out to 5. So just a quick note down on the bottom, don't forget the best way to represent your answer, reduced radical form. And so I have a note on that we'll review later. So if you do need to review this, again, check out the extra video that I'll have posted underneath this. You can also leave your answers as a radical if they don't simplify out nicely. That's actually the most accurate way. And so leave as a radical in reduced radical form. That's going to be your best option and the most accurate option for any of these problems. So again, check out the review video on reducing radicals if you need the extra practice or review from Algebra 1, and let me know if you have any questions.